put this guy on, okay? It's good, and then you just take these little clamps, goes on the opposite sides, okay? Now the best thing here is you keep these, they call them petcocks, you keep these things open. This is just a little ball valve, so this is open, and then this is closed. Okay, so initially you want to keep them both open. One of the things that we tell our guys is point the petcock at the examiner, because if you skip a step, he'll jump out of the way because he'll get shot with water. So, just something to think about. So you see him jump, you know you skipped a step. There you go. So basically, the next thing you do is you just fill this guy up with water. Okay. Until it pushes water out the other side. Okay. So you can kind of see how that. See how that is. Now, once it starts doing that, what you want to do is kind of tilt it on its side to make sure you don't, because you're going to get a little bit of air trapped up in here. Just kind of tilt it off to its side.
See those bubbles coming out? Yeah. So he's getting all the air.
So I probably overdo this, but I'm always afraid I'm going to get air trapped in there. So I'll probably spend more time messing around with this than I need to.
So now inside of that is nothing but concrete and water. No airs in it.
You do the other side too.
Yeah, I mean, basically what you're trying to do, and you can kind of see it when you look at it, you'll see a little bit of water down there that'll kind of move a little bit, so you can tell that, you know, none of the, what you normally see, if there's still air trapped in there, that water will start subsiding a little bit, you know. So now that we know we're pretty much good to go, this is the pump, okay? And what you do is you pump it up to the initial pressure, okay? And typically that's 3%, okay? You're supposed to calibrate this thing to 3%. You don't know that it's 3%, and that's, again, something you need to ask the examiner, okay? You ask the examiner, what's my initial pressure? And he'll tell you it's 3%, or maybe he'll give you 4%. I don't know, whatever it is. So
when calibration is done on this piece of equipment, the initial pressure changes according to how it reacts. You know, it can vary.
So you ask the examiner, Mr. Examiner, what is my initial pressure? And he says
3%.
3%. So you take this guy and you pump it up. Now you got two numbers here. This is the numbering sequence. Come around here. You see? This is the sequence here for actually the percent of air, and then down here at the bottom you can see, kind of at the very bottom, this is your initial pressure. Okay, see that stuff at the very, very bottom? Okay, so you got 0, and then you got a numbering sequence this way, and then you got a 0, and then a numbering sequence this way. Okay, so we're going to pump this. I didn't test this thing before I brought it here. I was hoping that it wasn't broke. So once you start getting up here, what you want to do is you want to tap the gauge to make sure that it's not caught. So you kind of pump it up. Now you can bleed it off of this little valve here. Okay, so if you over pump it, so let's just do that. So we got a little carried away, and we're over 3%. You can take this little knob here and you can twist it and bleed off the air. Okay, so then you can pump it back up.
Make sure you tighten it back up if you do that.
Once you bleed it.
Yeah, once you bleed, lefty loosey, and then
Right
back to right. Yeah.
Right, you tighten it up.
Exactly.
Okay, so right now you can see I'm at 3%. Okay, so we're good there. Now the next thing we want to do is you want to close these petcocks. Okay, because if you don't close the petcocks, the water shoots out and you guys will get sprayed. So what we do here is we can just close these guys off, okay? And then the next thing is see this little valve here, okay? You're gonna press this thing down, okay? So this is sort of the dramatic moment, if there is one. You press this guy down, and then you tap at the side with the rubber mallet to kind of jar any of the concrete loose to make sure all the air pockets kind of get filled up or whatever. Okay, and then as soon as you keep the plunger down, okay, after you tap it, let this guy down, and then you tap the side of the gauge till it stabilizes. Okay, you get all that? All right, so that's what we're supposed to be doing. So again, depress the plunger, tap that. There's a leak. You can hear it. See? Okay, and then you would tap the gauge like here. Okay, so that's what's supposed to happen. This is.
In reality, in the test, what happens if
that actually happens? The examiner then gives a choice to whether to let you redo it or not if there's a faulty equipment. He may actually have you redo it all over from the beginning. That's actually the first time that's ever happened to me. That's great that it happens while you're recording. This is awesome.
That's why I'm recording.
So then after that's basically it. You record, you report. See if we can get a real number on this. Yeah, that's not good. But let's say it stabilized here at this number, okay? If you look at that, okay, that's 3.6% air, okay? And so that's sort of your final answer. Okay, now the one thing I will say is before you give that answer, you need to ask the examiner, what's my aggregate correction factor? Okay, so with the pressure meter, if you do it correctly, there's an aggregate correction factor. And in reality, nobody uses an aggregate correction factor in the field. But for the exam, you need to ask the examiner, what's my aggregate correction factor? Okay. And so he'll say, I don't know, 0.4. 0.4. So you'll take this reading here, which is 3.5 minus 4, and so your final answer is 3.1% air. Okay. What did I say? Yeah, we don't want to do that.
Negative.
So 3.5 minus 0.4. It's your aggregate correction factor. So the concept is the reason why there's this correction factor is you have some aggregates that are porous, and so when you force this air down into the concrete, it pushes some air into the aggregates. So what you're trying to do is account for some of the air that gets pushed into the aggregate. So there's a whole nother test that measures your aggregate correction factor.
Believe it or not, there are tiny vessels in rock
Right.
that air can actually get pushed into.
So you want to account for that air with your aggregate correction factor. So again, you don't need to know how to calculate it. You just need to know to ask the examiner before you give them your final answer, what's my aggregate correction factor? So you take that number minus your aggregate correction factor, and then that's your final answer.
And with the pressure meter, it's to the nearest tenth of percent.
Correct.
So make sure you say, like, if that was, what was that, 4.1 after the correction factor, 4.1% air. Make sure whenever you're giving numbers on anything in the exam, make sure you give them actual units. Because if you just say 4.1, they'll just sit there and stare at you, you know, 4.1 what, you know? So 4.1% air.
And then this thing is, the chamber right now is still pressurized with air. So the best way to do it is to bleed it off the top, or you can bleed it off this thing and normally water shoots out. I was gonna see if I can make you guys jump, but since all the air leaked out because I didn't get a good seal, that didn't happen. So, questions on the pressure meter?
Not
Did I thoroughly confuse you?
Yep.
I have